So welcome to this talk. I'm going to share how we implemented Sigma at CERT-EU. You already had the notice. This is a TLP clear presentation. Feel free to take pictures and share information. So in this agenda, we're going to have a look at what is Sigma. We'll have a look at our context, and we'll share about our detection as code workflow. We introduced a tool for this talk, which we dubbed Droid, and we head over the conclusion and the key takeaways out of it. So what is Sigma? So Sigma was introduced in 2017 by Florent Roth and Thomas Patzke. Sigma allows you to create detection rules, and it is meant to be shared with other parties and integrated in security tools and SIEM and EDR. So the Sigma rules, so Sigma actually paved the way for a vendor agnostic approach. So here's you will have, so here's a view of a detection rule, so a Sigma rule. So you have metadata, so you have title and a description. And in the Sigma rule, you have two important fields here. You have the log source, where are you looking at, the detection fields. And your detection rules is quite easy to read, and you can share it with someone else. It's open and generic since it's standardized, and this rule is meant to be deployed to a SIEM and an EDR. So to achieve the conversion, Sigma introduced in 2023, Sigma, which is the engine that parse and converts the Sigma rule into plain SIEM query. So Sigma introduced two concepts here with Sigma. So first is the backends. So the backends are like your SIEM driver used by Sigma to convert a rule. If you want to convert a Sigma rule to Splunk, for instance, you will install the Splunk backend. As for the pipelines actually transforms the rule, and you will apply whatever condition you want for the rule, and so it will work in your environment. So how Sigma works as part of our detection engineer. So you would like to have a rule, for instance, to have a look at suspicious system user process creation, for instance. You head over the Sigma HQ website, you take a rule, and then you go to cconverter.io, which is a GUI, open GUI website to convert the rules. You put that, and then you have a rough idea of what your rule should look like. So you take that rule, and then you go over it on your SIEM, and it may not work because it doesn't reflect your production environment, because the fields that are displayed might not be the fields that are standardized in your organization. So you will go over for a manual task to make it compatible, and in the end, you will deploy it, if you like the rule, deploy it to in production. So to achieve, to ease that process of adapting a Sigma rule to your environment, you could apply a pipeline, which is a YAML file, also a YAML file that is applied in the conversion process to your Sigma rule. So here you have a rule condition based on a process access for Windows, and you will add, for instance, the index where you should look at for Splunk, or any Splunk hosts. In addition to that, they have introduced the post-processing pipeline, where you can standardize the output of your detection rule, which is, we'll come to that later, but it's quite critical for your operation. So in the end, putting Sigma in production for your threat detection service, is not easy. It works out of the box. You take that rule, you have a rough idea, it's nice, but you spend time in adapting your rule for your production environment. And Sigma is often criticized because it lacks of full integration with other SIEM, and is criticized for being not flexible. However, Sigma brought the long-awaited feature for the community, which is nice. So before we dig into our implementation and the technical aspect, let's have a look at our context, our CERT-EU. At CERT-EU, we serve 90 union entities, and for some of them, we offer security log monitoring. So see us as an MSSP, like for some institutions. So we face challenges with that. As you can imagine. We are dealing with cloud and on-premise environments, and obviously we deal with multiple SIEM and EDR for our clients. So we introduced detection as code. We embraced the concept to improve the management of our rules. So we wanted a vendor agnostic approach here. So one entry, Sigma, and throughout our activities, like threat hunting, post-breach, from a tip from someone, we create Sigma rules. And so Sigma rules, we put them on a Git repository. Okay, so that unlocks content versioning, so we know who and why the detection rules has changed. So from that Git repository, we'll use CI/CD pipelines to export those rules to SIEM and EDR. I'm using export here because it's our terminology to deploy detection rules. And since we use CI/CD pipelines, that unlocks quality assurance testing. So we could implement steps to verify the quality of the rules and if it works. Detection as code has many benefits here. So when I'm writing a rule, it can be reviewed by my colleagues, and together we can improve the rules so we can get a better detection rule content. So as part of our process, we have introduced a 4i policy where one of my colleagues, when I'm merging from develop to main, for instance, meaning production, my colleague has to validate all the content in the end, so that prevents for a blast of false positives and alert fatigue in the end. So all of that ensure continuous and iterative process. If I fail one of the steps, I will go back and redo until it passes the test we have implemented. So to ease that process, we have introduced a tool that we dub Droid. Droid is actually able to validate the rules on the syntax level, convert the rules, obviously, and search and report for findings in our dataset. Checks for integrity of the rules when it's deployed, and obviously you deploy the rules on SIEM and EDR. It's built in Python, and it supports Sigma and Plain's SIEM EDR native query as well. So how it works, it has a single tonal file, it is highly flexible, and within that file, you create a platform-based configuration where you will apply certain settings, meaning pipelines, to convert the rules as per the requirements of your platforms. So here's the Droid workflow. So in the main goal of Droid here is to take a Sigma rule or one or multiple Sigma rules and deploy it to multiple SIEM and EDR. But in between, we have introduced steps to verify the quality of the rules and test the rules. So first is to validate the rules as per the syntax. We'll get to that later. Convert the rule, search in our dataset, report for findings to uncover obvious false positives, and test rules using an adversary emulation tool, and ultimately deploy. If I fail one of those steps during the process, when I'm deploying a detection rule, I will go back and make sure that it passed all the tests implemented. So as for the validation, we are using the PySigma validation tool. So PySigma introduced validators. So you can check, for instance, your metadata if they are nicely done, or if you have failed one of the detection syntax, PySigma will tell you, okay, you have failed, here is an error. So that's what we are using. And it is well suited for the CI/CD pipeline since it raises errors. in the end, we validate the rule on the syntax level. Next, we obviously convert the rule. So the conversion is done by platform and log sources here. So for a given platform, you say, okay, you have to apply those Sigma pipelines in order to reflect my production environment. So you will make your log sources compatible with with droid. Once it's configured, you will have this process. So when I will convert a rule using droid, he will load the rule, obviously, and we take a look at the log sources, and we'll check within its configuration if it matches the platform configuration. And here, for a process creation on Windows, which is pretty common, we will actually apply some of the pipelines here. So on the upper left, you have a rough idea of how our detection repo looks like. So we have the pipelines, we have our Sigma rules, and when we convert the rule, it will make a match with the log sources, and we apply the configuration, the pipelines. So here, for process access on Windows, I want to add the index and some smoke server and some field-based condition. And of course, I will use the post-processing pipeline to standardize my output. So the benefit of that, I can have 10, 20, 30 detection rules for the process access. It will always be the same. It will always be the same, and it will be standardized. That's quite handy if you have a sole solution waiting for a standardized input. So if one day we want to change the fields and we want to deprecate a field, we have to modify a few pipelines, and that's it, instead of going over all the rules. Okay, so next step is to search in our data sets. So we take a detection rule, and droid will convert the rule using the pipelines, and we search on the SIEM. Okay, and we report back for false positives. Well, not for results. And if I have results, I'll take a look at them. So it may uncover obvious false positives, and sometimes few results, because you have to implement some filtering. And then you go back, you apply the filterings, you rerun, and there you go. It passed these tests. And Droid actually provides the the link, and then you can go over your SIEM and have a look at the data, of course. So as I said earlier, we are dealing with cloud environments. So sometimes we want to have a look at, we want to report for findings in many Sentinel workspaces. So we have developed MSSP mode, where we take a detection rule and we take a look at all the workspaces that we have access on. And that's at once, and that's quite handy also for the incident response. Okay, so that's what we are working on. So we are leveraging the Atomic Red Team project, which is an adversary emulation tool that emulates malicious activity on a workstation. So we have a workstation with the Atomic Red Team installed, and what we are working on is to have droid to execute the atomic test. For instance, grabbing the registry hive from the machine. So it will trigger that activity on the workstation, and that workstation has our log acquisition tool, so an EDR onboarded. So with that, it will take a look, it will produce the data, and we'll check if Android will actually check if the malicious activity was detected on the SIEM platform. With that, we raise our confidence of our log acquisition chain, and if our detection is accurate. So it's not bulletproof, of course. We still need to add more tests out of it, but that's work in progress. If it tests, if the test pass, the activity was detected, and Droid will not raise an error, and we go through. So as for the deployment, now we go back to the droid configuration file, the toml file. And as I said earlier, you have to configure your platform. And as many SIEM does, they work with safe search. So you configure your safe search, and all of your rules that are deployed will will have the same configuration applied. So if you want to change something, you modify your general configuration, and then you run the deployment, and there you go. You have modified all of your rules. That's quite useful, and we have introduced some of environment variables where you could replace to be used in a Git repository using CI/CD pipeline. In addition to that, we are using the rule level export configuration. So we apply a custom fields on the Sigma rule, and we apply specific droid settings here. So we can disable the rule, remove a rule, and override some actions. So for instance, webhook URLs, emails, whatever, and that can be replaced using environment variables. So as for the deployment, well, Droid is a command line tool, so you just run export and it will deploy your rule. And in the end, you can use another feature that we call integrity that will check if your rule reflects what it's supposed to be in the code on the SIEM platform and in the EDR. It will check if it respects the Droid parameters and will report for issues if there is any. So in the end, you have your detection rules uploaded to your SIEM, and it reflects what you have in the code with the compatible SIEM and EDR. So far, we support Splunk, Microsoft Defender for Endpoint, and Microsoft Sentinel, but we would like to add more. So now I'm going to talk about our usage of Sigma and our detection as code at CERT-EU. So we embrace the Git flow, Git branching system. So we have the main and the develop branch. So if I would like to integrate a new rule, I'll do my feature branch out of the develop, integrate that into develop. And if my colleagues would like to do the same, they will do it the same way. So feature, meaning detection rule, to develop. And then we merge the develop to main. But the main reflects our production environment, and the develop reflects our development environment. So we are testing here the whole chain of our infrastructure. So we are testing our SIEM, which is in dev, our SOAR automation, which is in dev, and our alerting system. So in the end, from a Git repository, it reached the alerting system. So that improved our collaboration and reduce risk of false positives. Of course, between branches, there are some validation that I was talking about that will raise errors and so forth. And actually, that improves our testing and validation steps. So in order to get started, so to use that process, you need to get familiar with any DevOps tool, obviously Git, and learn about Sigma. It's quite, it's well described on the website. There are many resources. The community is quite great. There is a Discord server where you can go and chat and ask for any help. And to use the same Git repository as us, just clone the repo that we have uploaded, and you can, after that, you can install Droid and start to configure your Git repository. If you already have a Git repository with detection rules, well, it is going to require some adaptation and some configuration with Droid, but it will work in the end. Okay, so as for the roadmap, we would like to integrate more SIEM and EDR, improve the correlation of the rules, not the PySigma in itself, but mostly the integration with Droid and Sigma. to allow a cross vendor detection rule based. Also, we would like to finalize the testing feature with Atomic Red Team and finalize obviously our documentation. And it's up and running. There are missing few precision about how it should work, but in the end, it's still usable. So now we head to the conclusion of this talk. So using Sigma for us is critical. It allows us a vendor agnostic approach to avoid locking by one of the SIEM and EDR. So we are able to move from a SIEM to another one. And obviously, as we work with multiple SIEM and EDR, it is quite handy for us to use Sigma. We built a wrapper for that, which I presented earlier, that should ease that process. And detection as code improved our service overall. So we were able to deploy detection rules much faster, and we have we have improved our quality assurance and unlocked content versioning. So some of the references displayed helped me a lot. The Sigma community is incredible. They helped me a lot. Sigma has a lot of documentation, and it is still evolving. Still today, earlier, Thomas Pasca released a blog post about the correlation feature on Sigma, which I do recommend. And obviously, people from David French and Anton Schuwer can help me a lot in understanding and embracing detection as code. So thank you for listening to me. And do you have any questions so far?
Thank you for an excellent presentation. I came up here with one question, but now I have a second one. What's the name of the main developer behind Sigma? I'm blanking on it right now. Florian, does Sigma now have a correlation feature?
Yes, it does now.
I've got an email chain with Florian as long as my arm where he was arguing that that would never be needed. So I got to like print that out. That's great. It's needed. So my question was, could you tell us a little bit more about your dev and QA environment and how you've got your tooling stood up and what kind of like fake data sources you're using? Just kind of like how that works.
It is actually, it's not fake data. We actually have access to our to the logs of the union entities we cover. Okay, so we are able to query those logs. Okay, and for some of them, we narrowed one of the best of them to using a dev data set. And in our development environment has access to that data set, which is still production data set.
But it's like kind of sanitized.
Yes, it's not all of the union entities. It's a narrowed version. So with that, if someone, push a detection rule, if it goes all the way to the alerting system on dev, if it blasts false positives in a way, we will see that before we merge develop to main. That's the main goal of that.
And do you have like sort of functional end-to-end tests for this, like between rule and alert? Well, so like if I introduce a typo that would break a rule so that the alert wouldn't fire, in your CI/CD system, is it like an end-to-end testing path?
Yes, there's still testing between those steps.
Great. That sounds like a submission for next year's conference, you know?
So yeah.
Thank you.
Thank you.
Hi. Yeah, thank you for the great talk. I just wondered, in the slide where you had you were actually testing the rules with the Atomic Red Team. When you write new rules, how does the testing process work with the Atomic Red Team? And secondly, if you're writing new Atomic Red Team rules, are you committing those back into the Atomic Red Team for the wider community?
So it's still work in progress. We would like to use it's already existing, making the test more robust. So the main goal is to trigger the malicious activity on the workstation and have droid look back on the data set to see if it's worked or not, using a filtering some rules. But yeah.
Okay, thank you.